Oh, hang on. Hello. I didn't get to see you this week. I have some thoughts I wanted to share in video form. And it's been on my mind for days and I just haven't. So here we go. First off, let's talk some exponent stuff. Okay. So, firstly, it's possible to raise exponents to things other than whole powers. So, like, sure, 5 to the 3. This marker was so good 10 seconds ago. 5 to the 3 is 5 times 5 times 5, right? Second chance? No. You are fired. We're trying blue. Okay. So, oh, that's better. 5 to the 3 is 5 times 5 times 5. Like that. But 5 to the 2.5. What is it? Weird is what it is. And we'll touch back on this in a minute. But just know that this is possible. Similar to multiplication, if you think of 5 times 3, just as like 5 groups of 3, then 4.5 times 3, might not make as much sense, because how can you have half a group? 4.5 groups of 3. But this does work. All you do is do 4 groups of 3 and then half a group of 3, or 1.5. Similar things apply. This is possible. Now, as I say, we'll get into how to do that in a second. The other thing you'll often see is negative exponents. So, like 5 to the minus 1, or 5 to the minus 12. All negative exponents like this. And that also seems weird, because how do you multiply 5 by itself -1 time or -12 times? Well, I will unfold this mystery unto you. So, the way I like to do this is we start here, 5 to the 1. That's just 5. Then 5 to the 2 is 5 times 5, so 25. And then 5 to the 3 is 25 times 5, so 125. And 5 to the 4 is like 675 or 625, something like that. I don't remember. But the point is that each step up you take multiplies by 5. So if you knew 5 to the 126, if you know what that is, then getting 5 to the 127 is really easy. You don't have to multiply 5 out 127 times. You just take 5 to the 126 and multiply that by 5. Each step up multiplies by 5. Well, as part of expanding this, we can also divide. Because if you start at 5 to the 3 and you don't know what 5 to the 2 is, all you have to do is do the reverse divide by 5. And similarly, to get back here, you divide by 5. So, based on that, what would you expect 5 to the 0 would be? Well, you take 5, you divide by 5 again, and that gets you 1. And notice, this applies for no matter what the base is. So, like 126 to the 1 is 126. 126 to the 0, you divide by 126, and that gives you 1. Like that. So, a common thing you'll see, a common like sort of standard identity is anything to the 0 equals 1. And this is true in all cases except where that bottom number is 0. There are some cases in which 0 to the 0 is defined, but for the purposes of your current classes, you don't have to worry about that. But anything other than 0 on the bottom, raised to the 0, gives you 1, because it's that divided by itself. Now, we can go further. So we took a step down this tree and got to 1. Well, now let's take one more step, 5 to the negative 1. We start here and divide by 5 again. And that gives us 1 divided by 5. Now, you could do this in decimal form, but it's much easier to just do fractions. 1/5, like that. Similarly, we can do 5 to the negative 2 and divide by 5 again. And that's going to equal 1/5 times 1/5. Because remember, multiplying by 1/5 is the same as dividing by 5. So 1/5 times 1/5, it's multiplication, so we just multiply straight across on the top and bottom. And that gives us 1/25. And now an interesting pattern comes in, which is that here is 1, that's kind of our center point. And then this is 5 and 1/5. And then this is 25 and 1/25. And this will hold. So because going up, we're multiplying the number, and going down, we're multiplying the number on the bottom, there's symmetry here. So the general way that you'll normally see this written, again, if we're making identities, is that, hang on, so we'd say that a raised to the negative b equals 1 over a to the b, like that. And this actually holds the other way as well. So basically, if you ever see something where if it's got a negative exponent on the bottom, that actually allows it to escape the bottom and just go up to being normal. So, like this. 1 over a to the negative b equals just normal a to the b. And this lets us do some really nice things with when we're trying to simplify fractions. So, for example, if I have a to the 15 times b to the 7 over a to the 12 times b to the negative 11. That's this for those of you who weren't keeping math at home. We can cross out the a's like normal. So a to the 15 over a to the 12, we just subtract. So that becomes a to the 3 on top. But this b, that's to the negative 11. And that's on the bottom, which means basically anytime you have a negative exponent, you can flip it to the other side of the fraction and change it to a positive. So in this case, that's a to the 3 times b to the 7 times b to the 11. So remember, exponents turn multiplication into addition. They sort of transmute it. And so that's just 7 plus 11 in the exponent, which gives us 18. And that's your answer. Okay. One more thing, and I'll be done. And this actually has to do with what we were talking about earlier. So, 3 times 5 can be thought of as 5 plus 5 plus 5. Or it can be 3 plus 3 plus 3 plus 3 plus 3. It's either 3 groups of 5 or 5 groups of 3. And it doesn't matter which. You can look at it either way, and it's valid. Exponents, that doesn't work. So 5 to the 3 is equal to 5 times 5 times 5, but it's not equal to 3 times 3 times 3 times 3 times 3. Those two things aren't the same. So because of that, we get really interesting things when we try to do the opposite of exponents. So with multiplication, because you can 3 times 5 is the same as 5 times 3, it doesn't matter which order you have it in. You can undo that multiplication by division. So if we wanted to undo multiplying by 5, we'd do divided by 5, like that. And this works if it's 5 times 3 or 3 times 5. You can undo the multiplication by 5 by dividing by 5. In exponents, the relationship isn't symmetrical like that. So we actually need a separate thing to, like a separate mathematical concept to undo the top of the exponent or to undo the bottom. So the way to undo the top of the exponent is with roots. So 5 squared, the way you undo that is you take what's called the square root, like that. We talked about this some. You've had some exposure to this. But just generally, the way you would do, like, the way you undo 5 to the 100 is by taking the 100th root. And generally speaking, the root of something asks, what number do you have to multiply this many times in order to get the number on the inside? Which is a little odd, but let's go through it. So take 25, and we're taking the square root, like that. What number do you have to multiply by itself 2 times to get 25? And the answer is just 5. So 5 times itself 2 times gives you 25. Similarly, we could try and take the third root of 8. I'm going to pause so you can like look at this for a second. What number do you have to multiply by itself 3 times in order to get 8? Try it in your head, try it on paper. It's 2. And we can see that 2 times 2 times 2. That is not a 2, hang on, that's a 3. So 2 times 2 times 2 gives us 8. So the answer to what multiplied by itself 3 times gives you 8 is 2. And that's the third root of 8. Now the opposite of this undoes the bottom of an exponent. So earlier we had 5 to the 3 and we took the cube root. And when you do that, this 3 cancels out with that 3, almost like it's a fraction, and you're just left with the 5. This one, it's called the logarithm, and it was discovered a lot later than the rest of the math we were doing, and because of that, we had run out of notation and we had to invent some more. So you write out the word log, that's short for logarithm, and you put a subscript. So most of the other times we're doing a superscript raising the number up. This case, we're writing the smaller number down below. So if we want to undo the top number in this exponent, 5 to the 3, if we want to undo the 3, we take the third root. If we want to undo the 5, we say that we take the logarithm base 5. And then similarly, that cancels out with that, and we're just left with the 3. Now, all of these we'll talk more about, but I just wanted to give you some preparation, and you can watch this several times. I know I really like in-person tutoring because it's so much easier to pause and let people ask questions. Final thing, I promised we'd talk about this. How do you multiply by like a fraction? Or how do you do an exponent to a fraction? So let's say, you want to do 5 raised to the 2.5, like that. Well, remember, adding in the top of an exponent is the same as multiplying outside of the exponent. So this is really 5 to the 2 times 5 to the 1/2. Like that. And I realize I gave no lead up for this at all, but the general form for this one is going to be this. Because exponents and roots are opposites of each other. So if I take the b root of a, that's the same as raising a to the 1 over b. So this here, 5 to the 1/2, is actually the square root of 5. And we've talked about this. The square root of 5, is asking what number multiplied by itself 2 times gives you 5. And the answer is it's just some infinite decimal. This is another one of those things very frequently when you're doing exponents, and especially roots and logarithms, you're going to encounter things that are too precise. Like it goes between all the little tick marks on the normal number yardstick. And, you can look closer and closer and closer, but it's just always right between the tick marks. This number is too precise to measure, but this is what it means to raise something to fractional powers. So, hope you have a good week, bro. Better than mine. I am looking forward to being able to nap, and you have a good one. We'll see you later.